Alright, in this video here I'm going to show you how to use a method of differentiation called the chain rule. So this technique is used to differentiate a composition of two functions. So let me quickly review that notion. So suppose I have the function f of x is equal to x to the 8th and g of x equals x cubed plus 10x squared. The composition of f with g is the function f of g of x. And to get f of g of x, we take the function g of x and plug it into the x in f of x. Okay, so in this case, f of g of x is x cubed plus 10x squared raised to the 8th power. Okay, the function that we're plugging in this case g of x, or x cubed plus 10x squared, that's usually called the inside function. Okay, the function that we plug it into, which in this case was x to the 8th, is usually called the outside function. Okay, now let's get to an example where we use the chain rule. I'm going to start by giving you a good working knowledge of the chain rule, and then we'll talk about the sort of more formal look at it, the symbolic look at it. Okay, here I have h of x is equal to x cubed plus 10x squared raised to the 8th power. Okay, so that's the function we were just looking at here. To get the derivative of this, we start by differentiating the outside function. Okay, so here we imagine that instead of having x cubed plus 10x squared being raised to the 8th power, we just have some variable x being raised to the 8th power. So then to differentiate h of x, we first differentiate that outside function, x to the 8th. So we have 8. We would have 8x to the 7th. But instead of putting x inside here, we're going to put our inside function inside there. So we get x cubed plus 10x squared. Okay, so here we have the derivative of the outside function, or 8x to the 7th, evaluated at the inside function. Okay, so the first step we have is we take the derivative of the outside function and evaluate it at the inside function. Okay, so 8x to the 7th evaluated at the inside function. And then we multiply that result by the derivative of this inside function. So times the derivative of x cubed plus 10x squared. The derivative of x cubed is 3x squared, plus the derivative of 10x squared is 20x. Okay, so now we have the derivative of x cubed plus 10x squared raised to the 8th is 8 times x cubed plus 10x squared raised to the 7th times 3x squared plus 20x. Okay, so we have the derivative of the outside function evaluated at the inside function times the derivative of the inside function. Okay, so that is how the chain rule works. All right, we're going to do a couple more because it seems a little hard at first, but once you get the hang of the chain rule, it's actually not too bad. Okay, so here we have h of x equals e to the x plus 8x to the negative 3, all being raised to the 15th power. Okay, so the first thing that we want to do is kind of what we did before, and we want to identify the piece of it that's the inside function. So the inside function is the piece being, or the portion that's being raised to the power. Okay, so the portion being raised to the power is this e to the x plus 8x to the negative 3. So then to differentiate this thing, we imagine that instead of having this inside function, we have an x to the 15th. So then the first step to get h prime of x is to differentiate x to the 15th. So if we differentiate x to the 15th, we get 15x to the 14. But instead of having the x there, we're going to have the inside function. Okay, so it's this 15 times something being raised to the 14th power. Instead of putting the x there, we put our inside function. Okay, so now this right here is the derivative of the outside evaluated at the inside function. And now we know we need to multiply that by the derivative of the inside function. Okay, so this gets multiplied by the derivative of this. The derivative of e to the x is e to the x. So plus the derivative of 8x to the negative 3. We bring down the negative 3, so that's negative 24, times x raised to the negative 3 minus 1, or negative 4. Okay, so we can clean this up a little bit. So we get that the derivative of e to the x plus 8x to the negative 3, all raised to the 15th power, is 15 times e to the x plus 8x to the negative 3 raised to the 14th, times e to the x minus 24x to the negative 4. Okay, so just another way we can think about this is we took the power, we brought it down, we kept the inside, subtracted 1 from the power, multiply by the derivative of the inside. Okay, so bring the power down, keep the inside, get the new power by subtracting 1 from the old power, multiply by the derivative of the inside. Okay, why don't you press pause while you work on finding the derivative of this function right here. Okay, so the first thing is we differentiate the outside function is going to be x to the 1/2. So we differentiate the outside, we get 1/2. We would have times x raised to the negative 1/2, but rather than having x, we have our inside. So we have e to the x plus 3 sine of x raised to the negative 1/2, then times the derivative of the inside, e to the x plus 3 times, oops, I just put it down. So times the derivative of the inside. The derivative of e to the x is e to the x plus 3 times the derivative of sine, and the derivative of sine of x is cosine of x. So plus 3 times cosine of x. All right, let's do a slightly different example now. So I'll say in this case, h of x is the cosine of x cubed, say plus 10x. Did I use that one earlier? 10x squared. I don't know why I like that function so much. Okay, anyway, so in this case, we're going to kind of imagine, again, the inside function. In this case, the inside function is what's being plugged into the cosine function. So we're going to pretend for the moment, to get the first piece, to get the derivative of the outside evaluated at the inside function, we briefly pretend that the inside function is just x. So then we pretend like we're differentiating cosine of x, and we know that the derivative of cosine of x is negative sine of x. Okay, so we have the negative sign, but we're not differentiating cosine of x. We're differentiating cosine of x cubed plus 10x. So rather than having negative sine of x, we have negative sine of the inside. And then we need to take that, so this is the derivative of the outside evaluated at the inside times the derivative of the inside function. So now times the derivative of x cubed plus 10x. So it's going to be 3x squared plus 10. And oftentimes if we have a trig function being multiplied by another one, we like to put that other function in front of the trig function. So we'll put negative 3x squared plus 10 times this sine of x cubed plus 10x.